out of all the tricks for adding 3D detail in video games, this is probably the coolest one: Parallax Occlusion mapping. You already know that we use image textures to define the look and feel of surfaces in 3D. In the backend, these images are projected onto the surface using a 2D coordinate system. And we can do fancy stuff like scaling the size of the texture. But we can manipulate the coordinates even more. And that is what parallax occlusion mapping does. POM is usually driven by a height map. A height map is a black and white texture that stores the height information of a detailed 3D surface, with white representing the peaks and black representing the lowest point on the surface. Using this height map, the system then shifts parts of the texture around based on the viewer's perspective, and this generates parallax, which creates the illusion of depth. Here, we have a flat surface with only 2 triangles, and this is what we use in-game. And here, we have the detailed 3D surface from which we are going to generate our normal map, which we covered how it works in the previous video, as well as a height map. I also want you to take note of the 3 points that I painted on here. So this is how the surface looks with just the normal map applied. You can see the illusion of 3D, but it's very surface level. And even at a low angle like this one, all the 3 points are visible, which does not make sense. And this is how the surface looks like with POM enabled. Much more realistic. And the dots appear and disappear as we would expect them to. So how does this really work under the hood? When we're using parallax occlusion mapping, the system uses the height map to recreate an imaginary 3D surface under the flat surface, and that's represented by this green. If we assume this is our eye and we're looking at a point on the surface, that's point A, if the surface was actually 3D, what we should be seeing is point B. So what we do is we plot upward to the surface and read what the texture displays at point C, and that is what gets rendered at point A. And that's how we are able to manipulate the coordinates of the textures and shift them around to create the illusion of occlusion. To calculate point B, we would need this distance, and the math for that is crazy. So what we do is we section the entire range into a bunch of layers, and we check when the view vector intersects with a layer. And that's how we are able to determine where point B is and plot that upward to point C. In fact, when you're viewing the surface at a very low angle, you can actually see the individual layers. Very cool. So that's how we use parallax to create an illusion of depth that's a bit more realistic than normal maps. Because of the math and the fact that every texture has to be sampled several times, this system can be a bit more expensive than normal maps. But the good news is that for most surfaces in games, normal maps are actually good enough. I hope this was fun and interesting and that you learned something. See you on the next one.